Hi viewers, welcome to LMS Solution. Today we are going to see about a bug and boost based grid-connected PV inverter system in MATLAB. This simulation model is developed based upon this following paper. We refer this paper, a bug boost grid-connected PV inverter for mismatched environmental condition. Here you can see that this is the circuit for that model. Dual bug boost based inverter, and then you will see the control logic here. This is the control logic for the buck boost based grid connected PV system. Here you will see that they are using MPPT algorithm, and then it will be processed via PA controller, and then it will be generate a power of PV. That means here we have two PV, PV1 PV2. Based on PV1 PV2, they are going to calculate VC not 1 and VC not 2, and then based upon that VC not 1 VC not 2, we are going to calculate RPCON by using this formula, and then based upon that RPCON and VC, the IL reference will be calculated in buck mode and boost mode. When the VPN is greater than or equal to VCON, and then it going to act as in the buck mode, and then VPN is less than VCN, then it going to be operate in boost mode. The IL reference for a buck mode and the boost mode going to be calculated based upon this equations. That means VCON divided by RPCON and V square CON divided by RPCON into VPN. And then after we are getting IL reference, that going to be compared with the ILM, and again when we process a PA controller, and then the PA controller output going to be considered as A and B, and then based upon again we are going to check the condition VPN VCON. If VPN is greater than or equal to VCON, then the duty cycle dB equal to A and dq equal to 0. Otherwise the dB equal to 1 and dq equal to 0. Based upon them, you have to generate the TP and DQ. This control logic is implemented in this paper. Same logic you are going to implement in the simulation model also. Here you will see that the simulation circuit diagram. You can compare this one. Here you can see that the PV is connected to the dual buck boost converter PV, and this portion known as a dual buck boost converter, and this portion is inverter, and it going to be connected to the grid. The next thing is here for each PV side we have to apply MPPT. Here we have first MPPT. So this MPPT will be generated and duty cycle or PV, and then here you will see that MPPT 1, and that means this is for a first PV panel, and this is for a second PV panel. This will be calculated duty cycle, and duty cycle going to be multiplied with the voltage. Finally, we will get to V reference. Here we will get V reference. This V reference going to be compared with the VP1 and VP2 PV panel voltage and the PV panel voltage 2. So this is first PV panel voltage. This is second PV panel voltage, and it going to be processed via PA controller. So this PA controller is generating PPV1, PPV2. This is based upon this control logic. Here you can see the common control logic. Then here the PP1 comes to here for calculating VC01, VC02. Here you can see that this is the circuit block for calculating VC01, VC02. After calculating VC01 and VC02, here we are going to generate RPC01 and RPC02. This implementation, this block implementation here. After that, we have to go for a control logic for the buck mode and this one. Here we are applying that control logic. That means this control logic based upon buck mode you have to calculate IL reference, and based on boost mode you are going to calculate the IL reference, and then again it going to be process via PA controller, and then you have to apply this condition for selecting the duty cycle. This is a control logic same implemented here. This control logic will be generate S1 and S2, S1 S3 and S2 S4. This is going to be used to control this circuit. Here you will see that S1, S2, S3, S4. This is going to control this circuit, and then here we need to control this inverter S5, S7, S6, S8. So you need to control that one. That going to be controlled by based upon that PLL concept. Here you will see that based upon PLL concept, you have to control. Y is nothing but is taken from here. The main here you are applying the PLL. Based upon PLL, we are calculating Y is it. Based upon Y is it, we are switching that S5, S8 and S6, S7. Finally, this pulse going to be used for control this inverter. These are control logic for controlling that converter. This one NPA system will be used for control this dual buck boost converter, and this logic used for control that inverter. And here they are tested the model, and the PV2 irradiation is fixed at some level. Here I am going to fix the PV2 irradiation maintenance 1000 watts per meter square, and then the PV1 irradiation will be changed by step varying condition, and then you have to check the results. So here you will see that here we are fixing in the irradiation for PV2 is 1000, and here you can see that wherein the irradiation of the PV1 one by one it will be changed from 500, 600, 700, 800, 900, and then 1000. And then you have to check these results. First we have to check this result of PP1 PP2, VP1 VP2 and IP1 IP2. So I'm going to simulate this model. Here you will see that results here in the figure 6, this one. Here you can see the result of this figure 6. This is PV1 power, this is PV2 power. Here you will see that this is a result of that blue color is PV2, red color will be PV1, and blue color is PV2 and red color is PV1. You will see that the same kind of result we are getting for changing irradiation condition. Next thing is you have to check the result of grid current at the grid voltage. Here you will see that detail. This is a grid current and the grid voltage. Here you will see that so grid voltage and current, and then here you will see that PV power of panel 1, panel 2, and PV voltage of panel 1, panel 2, and current of panel 1, panel 2. So you will get a similar kind of results. And current also you are seeing similar kind of result only. Current and voltage will be have similar kind of results. Here you have to zoom it little bit. You will see that in phase current, both are grid voltage and current having in phase component. This is a result of the model. As per that paper, you have got that result. This is working of that DL buck boost based grid connected PV inverter system. Thanks for watching our videos. Kindly subscribe our channel and also bell icon for notification about upcoming videos. Thank you. Thank you so much. Bye bye.